Hello and welcome back to part 5 of this KNN tutorial series in Python. In this particular video we are actually going to be finally training our KNN model, and then based on that trained model we're going to try and make some predictions and look at how accurate those predictions are. So before we do that, we actually need to import a couple of things from sklearn. And the first module we need to import from is this neighbors one, and we need to actually get our classifier, and that's going to be kneighbors classifier. On top of that, we want to actually see how accurately are we actually predicting or classifying these test values. So we need to come into this module called metrics, and from it we're just going to import one of the most basic metrics, and that's accuracy score. And what's wonderful about sklearn is we can actually implement all of this now in about 4 lines of code. And we're going to create this variable called KNN, or you can call it model, whatever you want to call it. It's going to hold our kneighbors class, well, object I should say, and we're going to initialize this class with a couple of parameters. Firstly, we're going to choose this neighbors parameter, and we're going to say this is going to be equal to 3. And what this is actually saying is that once we've trained our model, what we're going to do is we're going to get some test data, and we're going to compare this new instance of test data to its 3 most close values, and based on that it's going to try and classify it into the correct y-test features. So on top of that, the other parameter I want to include is this njobs equals -1, and this doesn't affect our classifier at all. It's just saying that if you have multiple processors, then use them. And I actually played around with a state here, so let's put this back to 42, but we will be playing with that a little bit. And that's it. So we've now got this KNN object, which is our KNN classifier. And now we're going to use this method called fit, and this is actually going to be training our classifier, and we can do that in 1 line of code, which is just phenomenal. And we're going to, what we're training it with, of course we're using our xtrain values and our ytrain values. And if you remember, our ytrain values were these our classes, and there was 3 classes or labels, whichever you prefer. And our xtrain data was our features or attributes, whichever you prefer. So based on the features, we're going to try and put them into the correct classifier, into the correct classes or labels. So that's it. Our classifier is trained. Now all we need to do is let's make some predictions. And we are, sorry, that's incorrect. It's not a function. We want that as a variable. And this is the predict method now for our KNN object. And all we're going to do in here is put xtest, because that's what we're trying to predict. So our xtest values, remember, that's the attributes of our test data, and we're going to try and put those into the correct ytest classes or match them based on our training. So all we need to now do is use this accuracy function just to see how good our classifier has performed. And we're going to use this dot format. This is just, you don't need to do it like this. If you want to turn this into a string and concatenate, you can do that too. And we're going to use this accuracy score function now given to us by sklearn that we imported at the top. And inside here we just need to do ytest. So those are our test labels, remember. Actually, let's make these smaller. Those are our test labels, and what are we trying to predict those to? What are we trying to get the accuracy score of? Our predict values. And all this accuracy score is doing is every time we classify something correctly, we get a 1, and every time we classify something incorrectly, we get a 0, and then it's just going to sum all of them and then divide it by our total number of things we're trying to predict. So that's going to give us a percentage score of how many times we predicted something correctly. Now, don't get me wrong, We are overfitting really here because we are training and testing on the same data set. What we really should do is we should split into 3 at least, or many folds, which we could do. So we're going to talk about them on the next video. But let's see how this looks. So we've made a mistake here because I've created our object with KNN neighbors classifier, and if you look at the top, there should be classifier. Hopefully there's no other mistakes. And that actually worked. So what we can see now is we predicted our values into the correct classes with 98% accuracy, which, you know, sounds pretty good, but it's all a bit flawed, but we'll talk more about that in the future. So we're going to go back to our Python script, and if you remember in a previous video I kind of said we chose this random state, and what this does is that it makes sure that every time we run our script we get exactly the same split of our test data. But if we actually change this to 3, we should get a different accuracy because it's now chosen different values for our test data and our training data. And you can see we got 94, so we get slightly less accuracy. And hypothetically, we should be able to get a value which is 1, possibly. Okay, and we got a 1 there. So we actually, so in this particular instance, so when we split our data up in this random state 43, we actually predict everything correctly, which is pretty cool. So hopefully you understand all that. I will be explaining it more in the blog post, so check out my website, check out the blog post, and like and subscribe, and I shall see you in the next video, and thank you for watching.